The kit includes 10 capacitors, 5 electrolytic capacitors, and the thing about the electrolytics, they are polarized. It makes a difference which way you install them. And 5 ceramic capacitors. These are all the same, these yellow ones. These red ones are not the same. The electrolytic capacitors are easily identified because they're actually just marked exactly the same way as they're marked on the schematic. The ceramic capacitors are identified on the schematic by size in microfarad, picofarad, and nanofarad. However, the body of the component is marked with the following numbers. The ceramic capacitors are identified with a rectangular box, and the component holes are inside the box, and the value is marked outside the box. And these are not polarized, so there's not a plus or minus on them. The electrolytic capacitors are polarized. The negative side of the capacitor has a white band on it. So when these capacitors are installed, you want to line this white smiley face with this band. The designer, or the board layout guy, gave us a plus symbol, and in most cases the positive lead is longer, so it goes in something like that. I decided to mark the capacitors with a black band. I tried putting a white band on this paper, but I couldn't see it. As I mentioned earlier, there are 2 potentiometers that are normally mounted off the board, and they'll be wired to these 3 terminal connectors. There are 2 onboard potentiometers. They mount vertically, and there's a screw at the top. Potentiometers are designated as VR1 through 4. The 10K pots are marked B10K, and those are these. The other 2 potentiometers, VR3 and 4, are 2K and 50K respectively. They're marked 202 and 502. On this board, they're designated as VR4, and to show a little screw, and can anybody see it? VR3. Well, we're just about done. There's an LM317 that would be placed here. I'm not sure whether to mount that on the board or not. And this resistor. It's a 1/10 ohm resistor. It fits here. I'm not sure why there's additional holes. Here's the completed board. I'm missing, I shouldn't say completed. Here's the board as I'm going to leave it tonight. I don't have the jacks installed or the terminals for the input or output. And I don't have these. This is a transistor in MOS. And this is a 3-terminal voltage regulator used for the fan. This is a good time to pick it up and hold it upside down and view through the board to a light source and see if there's any unused holes. Well, we have these 6 holes we know what we're going to do with. We have these 4 holes And we know what they're for. And of course we have 4 mounting holes. And the LED, which I may or may not socket. And we have this hole here and this hole down here, pretty well figured for a different physical configuration of resistor. And we have the empty transistor holes. I tried to mark these unused holes on the schematic, or on the printed circuit board layout. There are 2 more, or 4 maybe, unused holes that are only visible from underneath. And I don't know what these 2 are for. And these 2 are obscured actually by the filter capacitor. So I'm not sure what they're for. So we've accounted for all of the parts that were in the bag. We've accounted for all the holes that are on the printed circuit board. I will post all of this information after I update it, because there's some mistakes on it now. And the next thing we'll do is do some mechanical fabrication. Do something with this LM317. Get a heat sink and a fan, which we don't have. I'll get the stuff that wasn't supplied with the kit. And we'll do some mechanical assembly and test the board. Hopefully in 1 more video, maybe 2. So come back for the next video if you enjoyed this at all. You know the routine: thumbs up, comment, subscribe. Thank you.